You've heard the buzz, right? Those massive numbers being tossed around. 1 million tokens, 10 million tokens. It really feels like a full-blown memory arms race in the world of large language
Oh,
models.
absolutely.
But for you, building and deploying AI, what does a 1 million token context window actually mean for your projects beyond just being a big number?
Yeah, that's exactly the question. And that's precisely what we're here to unpack today. We're taking a deep dive into the latest developments in LLM context windows,
Ah,
specifically zeroing in on the recent release of MiniMax M1 and its bold claims as it goes head to head with its rival DeepSeek.
hmm
We'll pull insights from, a stack of sources, from lively Reddit discussions to industry blogs, technical reports, basically trying to help you understand the architectural innovations, the real-world performance, and most importantly, the practical implications for what you're building.
Right. Our mission here is really to cut through the hype and give you truly actionable knowledge. We're going to start by demystifying the context window itself, just making sure we're all on the same page.
Good idea.
Then we'll zoom in on MiniMax M1's groundbreaking features, compare it directly to DeepSeek. We'll look at those efficiency claims, the tech underneath.
Yeah, the nuts and bolts.
Exactly. And then pivot to let's be real, the challenges and also the exciting opportunities these massive context windows present. From hardware demands to smarter deployment strategies. Let's get into it.
All right, so to kick us off, what exactly is a context window? Simply put, it's the maximum amount of information an LLM can sort of remember or process at one time,
Okay.
to understand your query and generate a coherent response. Think of it as the model's short-term memory.
Short-term memory, got it. And these tokens, they're like the basic units, words, code.
Exactly. Tokens are the fundamental units. They can be words, parts of words, lines of code, even elements from images or videos sometimes. It's the stuff the model reads.
And this memory size, wow, it's been expanding at a truly incredible pace. I mean, it wasn't that long ago that early NLP models were stuck with just a few hundred, maybe 1,000 tokens.
Right, tiny by today's standards.
Then GPT-3 came along, pushed it to 2,048 tokens. That felt huge at the time.
It really did. A big leap.
Fast forward, GPT-4 hit 128,000 tokens. That seemed enormous. So what's happened since then? How did we get to talking about 1 million tokens as the new frontier?
Well, it's happened fast. Just recently, we've seen models like Google's Gemini 1.5 Pro. It has a standard 128K window, sure, but it also showed this breakthrough capability, consistently running at 1 million tokens.
1 million consistently. Okay.
And they even tested it up to 10 million, so it's a significant jump. And it's not just Google. Alibaba's Qwen 2.5 1M also made waves. That's an open source model hitting the million token mark.
Open source. Interesting.
Yeah, and Meta's Llama 4 Maverick similarly offers a 1 million token context. It really signals this concerted industry push. Everyone's chasing longer context.
And I think I even saw like Magic.dev's LTM2 Mini claiming 100 million tokens. Is that right?
Yeah, staggering 100 million. It's genuinely mind-blowing when you think about it.
It really is. But, okay, bringing it back down to earth for our listeners, what does this kind of capacity, specifically 1 million tokens, actually mean in practical terms? Like, what does that look like for a developer?
That's a great question because, yeah, the raw number needs context, right? 1 million tokens. That means an LLM can process roughly 50,000 lines of code in one go.
50,000 lines.
Okay, that's substantial.
It is. Or, to put it differently, it's like the equivalent of 8 average-length English novels.
8 novels.
Yeah. Or even the transcripts of over 200 average-length podcast episodes. It's just a massive amount of information for an AI to hold in its working memory simultaneously.
And that's exactly why this expansion fundamentally changes how you can interact with and leverage these LLMs. Historically, with limited context, you had to use clever tricks, right?
Like just dropping old messages or summarizing things, or using retrieval augmented generation RAG with vector databases to kind of fake a longer memory.
Exactly. All those workarounds.
So is that whole paradigm shifting now? Do we just stuff everything in?
Well, it definitely invites a shift. Instead of constantly fighting the limitations, the idea now is you can provide all the relevant information up front. And that enables much more robust in-context learning. The model can grasp nuances it just couldn't before. And this opens up entirely new use cases. Imagine, like, deep analysis across a huge legal document.
Right, without breaking it up.
Or creating AI agents that have genuine long-term memory across complex tasks. Or even processing video and audio directly within the context. It's pretty transformative.
Okay, so these massive capabilities are emerging. Everyone's pushing the limits. Who's actually delivering on this now in a way developers can access? And that brings us to this new challenger, MiniMax M1. Tell us about it.
Right, MiniMax M1. It's being introduced as the world's first open-weight, large-scale hybrid attention reasoning model.
Open weight. Okay.
And crucially, it's released under an Apache 2.0 open source license. That's a significant plus for you, the developer. It means more control, more transparency.
Yeah, that open source part is always a big deal for the community.
Definitely. It's not just some paper behind closed doors. It's a tool you can actually get your hands on and tinker with.
Okay, so the open license is key. Now let's dive into the tech itself, the architecture. You mentioned it's a unique hybrid mixture of experts MoE architecture combined with a lightning attention mechanism.
That's right.
What makes this particular combo special? How does it actually handle that massive context efficiently?
So the hybrid part is interesting. At their core, MoE models are divided into these smaller expert neural networks, right? The efficiency comes because the model only activates the most relevant experts for each token it processes. It's like having specialists for different tasks.
Instead of everyone doing everything.
Exactly. So MiniMax M1 has this huge total parameter count, 456 billion. But, and here's the key efficiency point, it only activates about 45.9 billion parameters per token.
Ah, okay. Much less.
Way less. This selective activation, plus their specific lightning attention mechanism, is how they manage to handle these large contexts without, grinding to a halt or costing a fortune in compute.
Makes sense.
Yeah.
And how large a context are they actually claiming here? Are they really in that million token club?
Oh, yeah. They natively support a 1 million token context length, and they even say it's expandable to 4 million tokens during inference.
4 million.
Wow.
Yeah. And this is a direct challenge, right? They're explicitly positioning it against DeepSeek, saying MiniMax M1's million tokens is 8x the context size of DeepSeek-R1.
8 times.
Yeah. And remember, DeepSeek-R1 and the newer V3 currently offer 128,000 tokens. They also use MoE, so it's a real head-to-head on architecture and capacity. An 8x context claim is definitely bold. But okay, that brings us to the crucial efficiency question and what the benchmarks actually show. MiniMax M1's big selling point is efficiency, thanks to that lightning attention. How does that translate into real benefits for developers?
So the headline claim is that it consumes only 25% of the FLOPs compared to DeepSeek-R1 at a generation length of 100,000 tokens.
Only a quarter of the computational operation.
Exactly. And for you, the developer, that's potentially huge. Lower FLOPs mean significant cost and resource savings when you deploy these models, especially as context sizes keep growing. It's about getting more bang for your buck, computationally speaking.
That kind of efficiency sounds amazing, almost too good to be true sometimes. But beyond the architecture, what about the training data for MiniMax M1? Did they do anything special there, especially for software engineering tasks?
That's another interesting angle. They state it's trained using large-scale reinforcement learning, RL, on diverse problems. And they specifically mention sandbox-based, real-world software engineering environments.
Ah, so they explicitly trained it on coding problems.
It seems so. This specific focus suggests it's really designed to excel at the practical tasks many developers are grappling with, not just general language stuff. They used a novel algorithm called CI-SPO for this RL training.
Okay, let's talk numbers then. Benchmarks. On SWE Bench Verified, that's a software engineering benchmark, MiniMax M1 80K scores 56.0. How does that stack up?
Well, the original DeepSeek-R1 scored 49.2 on that. A later version, DeepSeek-R1 0528, actually hit 57.6. So on that specific benchmark, MiniMax M1 is very competitive, maybe slightly behind the very latest DeepSeek iteration.
Okay, competitive, but where does it really pull ahead then, according to their claims?
The real differentiator seems to be in long context understanding. That's where the benchmarks get really interesting. On OpenAI MRCR, which is built for long context tasks,
Right.
MiniMax M1 80K achieved a score of 73.4 at 128,000 tokens. That significantly beats DeepSeek-R1, which got 35.8, and even the newer DeepSeek-R1 0528 at 51.5.
Wow, that's a huge gap on long context.
It is. And at the full 1 million tokens, MiniMax M180K scored 56.2. DeepSeek didn't even have a reported score at that length on this benchmark. So the claim seems to be less about general coding prowess and more about mastering tasks that require understanding vast amounts of information.
So the takeaway is MiniMax M1 claims to outperform models like DeepSeek-R1, particularly on complex software engineering, tool use, and especially these long context tasks. That's a big claim for developers building sophisticated AI tools.
Absolutely.
But let's be real for a second. These massive context windows sound great, but the hardware demands must be intense, right?
Yeah.
What's the practical reality check for developers trying to actually use these models?
Yeah, that's the significant hurdle. It's not trivial. For instance, a model like Qwen 2.57b Instruct, even the smaller 7 billion parameter version, needs at least 120 gigabytes of VRAM across GPUs for its million token variant.
120 gigs of VRAM.
Yeah, and the 14 billion model jumps up to 320 gigabyte. As one developer joked on Reddit, my 16 gigabyte laptop just had a nervous breakdown hearing that.
Yeah, I bet.
It really highlights the scale of the challenge, especially for local development or smaller setups. Now, quantization can help a lot.
Reducing the precision, right?
Exactly. It can significantly cut down memory needs. Like one example showed a 74,000 token novel fitting into 24 GB of VRAM after quantization. But even 24 GB is still a considerable barrier for many.
Okay, so memory is one major challenge. What about speed? I heard about pre-fill latency.
Yes, the time to first token problem. Even if the model can hold a million tokens, processing all that input before it generates the first word can take a while.
How long are we talking?
Well, Meta's Llama 4 Maverick, running at a million tokens on a pretty high-end server, reportedly can take over 2 minutes just to generate that first token.
2 minutes. That kills interactivity.
It absolutely does. For chatbots or any interactive application, that kind of wait is often unacceptable. So while the potential is huge, these practical hurdles, memory and latency, are very real.
And you see skepticism online too, right? Like on Reddit, people saying being able to inference on 1M tokens means nothing if the quality of reasoning over that context isn't there.
Exactly. There are valid concerns. Can the model truly find the needle in that million token haystack? Or multiple needles? Reports are mixed. Some users have great initial results. Others find the performance on complex long-range reasoning tasks still pretty terrible. It's early days for practical usability at this scale.
Plus the cost implications. Bigger context means more compute, slower processing, higher bills, especially if you're paying per token on a cloud service.
Definitely. Longer context equals more cost, generally speaking, both computational costs and actual dollars if you're using APIs.
Okay, so we've got the challenges. Memory, latency, cost, maybe even reasoning quality at scale. But you mentioned optimizations are emerging. What's being done to tackle these issues and make these models actually usable?
Right. This is where things get clever and offer some hope for practical deployment. One key area is KV cache offloading.
KV cache, that's a model's internal state, right?
Exactly. The key value cache stores intermediate calculations, the model's memory of the context so far. It gets huge with long contexts. Technologies like NVIDIA's Dynamo library let you offload this cache from expensive, limited GPU memory onto system RAM, or even fast NVMe SSDs.
Okay, how much does that help with the latency?
Potentially, a lot. Consider this. Reloading a million token KV cache from system RAM might take just 15 milliseconds.
Wow, compared to minutes for recomputing it.
Precisely. Even from an NVM drive, it might be around 140 milliseconds. This dramatically slashes that painful time to first token for subsequent interactions within the same long context. It massively improves the total cost of ownership, too.
That sounds like a genuine game changer for interactive apps. And you mentioned Google's Gemini offers context caching, too. How's that different?
Yeah, that's more about the billing model for certain use cases. For things like chat with your data apps instead of sending the entire documents tokens with every single user query.
Which gets expensive fast.
Right. With context caching, you can upload the file once, pay a fee perhaps on a per-hour basis to keep it cached server-side, and then subsequent queries only bill for the new question tokens, not the whole document repeatedly. Makes those kinds of apps way more economical.
Gotcha. So smart caching strategies, both technically and commercially. And I guess developers can also be smart about how they use the context window.
Absolutely. Things like adaptive context windows, only using the full million tokens when truly needed, plus techniques like pruning less relevant parts of the context, using sparse attention mechanisms, batching inputs. There are ways to manage the costs and performance.
Okay, so despite the challenges, there are solutions emerging. Let's pivot back to the opportunities for software developers specifically. With models like MiniMax M1 and DeepSeek pushing these long context boundaries, What new things can you actually build?
This really opens up some exciting possibilities.
Yeah.
First, think about comprehensive code base understanding. Imagine querying your entire code base, maybe tens of thousands of lines, in one go.
Asking questions about the whole thing.
Yeah, identifying bugs across multiple files, getting suggestions for complex refactoring, generating new code that perfectly fits the existing architecture, all within that single massive context. No more needing to feed the model tiny snippets.
That alone could be a huge productivity boost.
Yeah.
What about automating bigger software engineering tasks?
Definitely. You could leverage these models for things like automatically documenting an entire complex software system by letting it read all the source files, or performing really thorough security audits by reviewing the full code base for vulnerabilities and context.
And agentic workflows. AI agents that do stuff.
That's another big one. You can build AI agents that can genuinely think extensively about a problem, maintaining memory and context across many steps or interactions. This allows them to tackle much more complex, real-world software engineering challenges than previous agents could.
That sounds powerful. And crucially, how easy is it to actually deploy MiniMax M1? Because great tech isn't useful if you can't run it.
Good point. They seem focused on accessibility. MiniMax M1 offers multiple ways to deploy. You can download the weights directly from Hugging Face, which is standard now.
Okay.
You can use it with the popular Transformers library. And interestingly, they specifically recommend using VLLM for production environments.
Why a VLM?
Because of its, quote, excellent throughput, efficient memory management, and powerful batch request processing capability. It's optimized for running these large models efficiently in production. Plus, MiniMax M1 supports function calling.
Vital for agents interacting with tools and APIs.
Exactly. It allows the model to call external functions or APIs, making it much more useful for building practical applications.
So, okay, the big picture here seems to be that these massive context windows invite a more direct approach. You can potentially just give the model all the relevant information up front for really powerful in-context learning. Does this mean things like RA? Are they becoming obsolete?
That's the million-dollar question, isn't it? Or maybe the million-token question.
Sure.
I think it's more nuanced. The ability to provide everything up front is definitely game-changing for many use cases. It can drastically simplify things, but the jury is still out on how well these models perform with finding one specific piece of information, the needle, versus multiple needles within that absolutely enormous haystack.
Performance might degrade.
It might, especially for very complex retrieval tasks across the full context. So for now, I'd say massive context is a powerful new tool that significantly reduces the need for agate in many scenarios, especially where the core information fits within the window. But RGAC might still have a place for truly gigantic dynamic data sets, or where pinpoint accuracy on specific facts is paramount. It's becoming more of a complementary tool, perhaps.
Okay, that makes sense. So we've taken a real deep dive today into this world of long context windows. We highlighted how MiniMax M1 is making waves, challenging DeepSeek and others with its hybrid architecture, those efficiency claims, and strong performance, particularly in complex long context tasks relevant to software engineering.
Yeah, and we also hit the practical side, the very real hardware demands, the latency issues, but also the crucial optimizations like KV cache offloading and context caching that are actually making these huge contexts start to feel usable.
Right. So as these LLMs continue to expand their memory, potentially holding entire projects, long conversations, massive knowledge bases, it really does raise some fascinating questions for the future, doesn't it?
It really does. Like, will these ever-growing context windows eventually just absorb the function of things like external vector databases for many AI tasks? Will they fundamentally simplify the typical AI application stack?
Or will we just hit new, unforeseen bottlenecks at even larger scales? Will we need totally new architectures again when we're talking billions of tokens?
It's entirely possible. The scaling challenges might just shift.
Indeed. It's definitely a space moving at lightning speed. So the final thought for you, our listener, what seemingly impossible problems, maybe in your own software projects, will you be able to tackle when your AI assistant can genuinely remember and reason across an entire code base or whole book without losing the plot?
The possibilities are just starting to unfold. It's going to be really exciting to see what developers like you build with these new capabilities.